Okay, welcome everybody to this session. I'm Laurent, the room manager, and I'm very delighted to introduce Prashant and Khan, who will present about Lakehouse Federation. Guys, over to you.
Awesome. Thank you for the introduction. Hey all, morning. Hope you're having a good morning and start your summit this time around. I'm John, spelled C-A-N, and then pronounced John. And then I'm here today with Zeashan.
Hi guys.
We're going to be talking about, all the exciting stuff we're doing on the Lakehouse Federation side, and some of the updates that has happened over the last few years or so. I'm sorry, months or so. All right. So just as a reminder, a lot of the stuff you're going to see is forward-looking. Stuff might change without notice. I'm going to skip the intros here. So just one kind of main point to start here is when we kind of look at our customers' data ecosystems, right, their data is scattered, right? Whether that's multiple warehouses, multiple data lakes, multiple transactional systems, and a lot of platforms to kind of wrangle all of this data together, right? It's not really in one place. But your analysis kind of needs to be across all of these different silos, right? And when you kind of look at it, right, you start with these different data sources and formats. You kind of end up with, which makes you end up with different metastores, which ends up having to make you have different governance layers. Right now, you're not only replicating your data or your metadata or having to move it so that you can join stuff together, but you're having to manage the governance multiple times. And then when you kind of put all of this together, there's a lot of work, a lot of complexity, right? To be able to, join your transaction data to your customer list, you have to go through all these hoops. Which is kind of crazy when you think about it. And Lakehouse Federation is the solution for this, right? What we're saying is hey, as a step before you do ETL, right, as a step for you to be able to do discovery, analysis, being able to kind of reach all of this data and be ready to be able to ingest or do something with it, right? What we're saying is federated within Unity Catalog, have access to all that metadata, all that table information, all of that catalog information, as if they were internal tables, right? Do your exploration, and then once you're kind of ready, do whatever downstream dashboarding, ETL, ML, you name it, whatever you want to do. And the way we look at it, we have two kind of types of federation that we kind of keep in our minds. One of them is the database federation. And an easy way to think about database federation is if you're pushing down to another system to run the query, right, as in pushing down execution. That's what we're kind of calling database federation throughout this presentation. And on the catalog federation side, this is everything where we get the information about where the tables live, what their format is, but as opposed to pushing down to, let's say, these other systems, right, we execute within Databricks using that metadata that we got from other systems. So kind of two flavors here, right? Both of them are kind of valuable in one, right? On the left-hand side, databases, you kind of need them to be able to, so that you can use it for transactional systems. But if you're an open catalog, maybe you have that other systems. And Zeashan is going to cover a lot more into when this makes sense or not. But the whole point is we're kind of invested in making this work great and work across a lot of different types of databases. And when you can kind of think of the benefits, right? One of the first one is you have everything in one place. Right, I can search about it. I can see the lineage about it. I can kind of see all the permissions. You have this unified view. The second one is, which kind of comes with the unified view, is you can kind of govern it once, right? You can basically say, hey, if I want to have, different, assets with this row level policy or this column level policy, but I want to make sure that when I join these two tables together from different systems, that applies, you can do that now. Because what the federation gives you is these foreign tables, these external tables, behaving just like any other internal table. And our customers love it, by the way, right? When I presented this first time, 2-3 years ago, right, we were actually in some tens of thousands of queries. But now we see millions of queries a day just going through federated Unity Catalog connections. And this is not even counting legacy non-UC federation work that already happens in Spark, which is a huge part of it as well. So there's a lot of kind of demand on using Lakehouse Federation as a way for you to discover, analyze, and govern before you kind of decide what you exactly want to do with that, that workload. And to kind of give you a bit more details about how it works, how kind of things plug in together, I'll hand it off to Zeashan.
Thanks, John. Hopefully you guys can hear me. Maybe?
Yeah.
Can you guys hear me? Excellent. All right, so we're going to talk a little bit about how this works. So as John mentioned, there's two types of Lakehouse Federation. There's database federation, which again is the, maybe your traditional RDBMS. Query execution is sort of happening inside the database that you're pushing down into, and we'll talk about exactly how that works in a second. And the other type is catalog federation. So let's go through each of those. So in the case of database federation, your query is pushed down to the external database, right? And you're effectively leveraging the remote compute of that particular database, so whether that's SQL Server, Teradata, Oracle, so on and so forth. We'll utilize APIs such as JDBC to be able to communicate with that database and push some part of that query back down into that database to be performed, and then the results are aggregated and sent back to your Databricks worker node. And the obvious, most common use cases for this are things like ad hoc reporting, also proof of concept work for ETL pipelines. So if I'm like building a particular pipeline and I want to actually look at the upstream data and test some queries on it, test some operations on it before I actually start ingesting that data, database federation is a wonderful way to help with this, as well as also just broadly to be able to discover all the different data sources that exist in your enterprise without necessarily having to go through the effort of ETLing them in order to start realizing value. And there we go. And the next one is catalog federation. So in the case of catalog federation, as John was mentioning, your query actually runs directly against file storage. So wherever the data lives, an iceberg table, a delta table, the table metadata is basically synchronized from the external catalog. So think HMS, think iceberg rest catalog, think glue data catalog. We'll go grab the metadata from there and we'll actually read the data on disk, on cloud storage, wherever it lives. And obvious use cases for this are hybrid models where I've got maybe different data catalogs in my enterprise, different autonomous units that are sort of managing and maintaining their own catalogs, or perhaps like a step in migrating to Unity Catalog in the case of HMS Federation, which we'll talk about shortly. So how does this all work, right? So the first thing you do when you actually want to set up Lakehouse Federation is you go set up a credential. And the credential is exactly what you think it is. It allows UC to be able to interact with that external system, whether it's a database or an external catalog. And effectively, you can do this via SQL, API, or via our UI. You see here we have all these different fantastic options: Snowflake, Databricks, Salesforce, MySQL. I think there's more in this list than we have space for on the screen, which is pretty cool, and that shows how much progress we've made since rolling this out, which is really exciting. Once that connection is set up, you can then create a foreign catalog in UC, which basically points to that connection. So it'll utilize that connection and reference that connection when you create it, right? So if you look down here, using connection name, right? Like that's in the SQL syntax for creating this foreign catalog. And you can pass additional options to it as well and kind of tell it where you want to mount it effectively inside the UC namespace hierarchy. And then once that's done, you can now query it like it's a table that lives in ADLS or S3 or GCS. You can query right alongside the rest of your data, which is pretty phenomenal if you think about it. Because I might have some data that lives in a Snowflake instance that's locked in, or a Teradata instance that has been around for ages, and I want to bring that data and start querying it alongside data that lives in my lake, but I don't want to necessarily go through the headache of upfront ETL in order to determine if I can derive value from that data, right? So this helps you kind of fast forward that process in terms of making that determination up front whether or not it's a key part of your value journey. Now, when I run a query and I actually perform the query, what actually happens is we do something called an intelligent pushdown. So I run this query, for example, selecting age and account, right, from this particular customer table in some database in this example here. And the Databricks Query Optimizer will actually go and translate the operations in that particular query into the appropriate SQL dialect for that downstream database. And what ends up happening is all the things like filter predicates, so for example, the where clause, where region in North America, that's actually pushed down into the database and run on the database. The aggregation for the count also pushed down to the database. The scan and projection, right, actually just selecting the age group and field from that particular table. All of those things are pushed down into the source database. So when we get the resulting data back in UC in Databricks, it's targeted and small, right? So this is good for multiple reasons. One, we're not sending a whole bunch of data over the wire, which would be wildly inefficient, but also we're not asking too much of the database, right? So we basically do this in a very intelligent fashion so that you're not, putting too much load on a database, which, frankly, aren't meant to scale or meet the scale requirements as well as your compute in a lakehouse might be. Catalog federation, as I mentioned, works a little bit differently, right? So I run, let's say, a similar query, right? What happens here is I'm actually going to go and grab all the files. But before I go and grab all the files for this particular table, I'm going to verify the file and metadata by going and talking to that third-party catalog. So I'll make a call out, like the Databricks executor node will make a call out to Glue or your Iceberg REST catalog or HMS, verify the location, path information. It'll go read from the metadata that's on disk for Delta or whatever the particular file format is, and then it'll execute it like it was a native file or a native table that was just registered in Unity Catalog. So the benefits here are pretty clear, right? Like you use the native engine execution on storage. You're not paying for compute in two places, which is pretty cool. But then most importantly, like from a requirements perspective, this really only works with Lakehouse Catalog. So I mentioned things like IRC, Glue Data Catalog, et cetera. Catalogs that effectively support open table formats and open cloud storage. And this is exactly what Catalog Federation is for. And both these together, right, they combine and they create the full Lakehouse Federation picture. And the cool part about this, I don't know if you guys are aware, but like this is already a core part of Databricks pipelines, right? So like example here of like a lineage graph where you can see all these different upstream sources that are coming from different Lakehouse federated tables that are landing their way into tables that live inside Unity Catalog and are on open cloud storage and are being of course like then used out to create other further derivative tables. So this is pretty exciting stuff if you think about it, and it's an integral part of our platform. So I'm going to walk through a couple recent updates. First and foremost, I'm pretty proud of this because I think this is pretty awesome. We've finally announced some amazing connectors. So we have an Oracle connector, which allows you to, of course, connect and query Oracle databases, Exadata, and more. We also recently announced a Teradata connector. So now you can connect your Teradata instances to Unity Catalog using Lakehouse Federation. And we also went through a recent pretty big upgrade of our BigQuery connector. So now we're using the latest BigQuery connector from Google, which gets you better performance and better feature capability as well. We also added in on the Catalog Federation side some more exciting pieces. So the one I'll focus on first is Hive Metastore. And this is a pretty big deal because Hive Metastore now gives you the ability to federate and query HMS. So if you think about the Unity Catalog migration journey, what most customers, and probably many of you in this room, had to do at some point was use a sync command and sync tables from Hive Metastore to Unity Catalog and kind of go through this step-by-step migration. The beautiful thing about having Hive Metastore Federation is you can actually federate the existing catalog that you have, right, whether it's an external or internal catalog, and immediately start using getting all the UC benefits of governance on top of that right away without having to necessarily migrate your tables. So this is a pretty big deal. And this is also now generally available. And we've also rolled out support for the Salesforce Data Cloud, which again is another catalog-based federation connector, as well as AWS Glue. So this kind of completes that like total picture of catalog federation that we're trying to get to. So what are our customers actually doing with this? So we've talked about a couple of use cases, and I'm gonna dive into a little bit more. So I think the most obvious use case that we hear from most customers is that they just want to figure out what's in a particular database, right? Like, I mean, you're a data team, and there's probably thousands of different database applications that exist, or database servers that exist in your enterprise. You have no idea what half of them do, right? And chances are you don't have a catalog, an enterprise catalog that's up to date, and you have all these different transactional sources. And there's useful data in there, right? There's really good data in there that you don't necessarily have pipelines for, that you can't immediately operationalize and make use of in providing your data analytics. And obviously then discovery, right, is one of the most important bits. So once you have a database, you can just add it via Lakehouse Federation, and now with that data registered, you can govern it, you can provide security on top of it, but more importantly, you can just use it to figure out what's in it, right? You can run queries against it, you can use it against other master data or other data sources that you have in UC, and try to derive value from it. Most importantly, you can also query it, right? So like getting a single view and being able to securely explore all of this data without having to ingest it is pretty powerful. Now, We don't necessarily recommend that you replace all your ingestion pipelines with Lakehouse Federation, but it does certainly make the process of getting to data for the purposes of ad hoc reporting or other one-off use cases a lot simpler. And obviously, if you need to scale it up to a much wider consumption, then possibly at that point you can make that business case as to whether or not it makes sense to ETL it in. The governance piece is really important, and John mentioned this, but like you get all of the lineage insights, you get auditing, you get permissions, so things like row-level security, column-level masks, right? A lot of these things simply not possible in the source database in some cases. You can get all of that with Unity Catalog, so even just replacing that query layer with UC and Databricks for all of these gives you that single homogenized view of your data estate regardless of where the data actually lives, and that's pretty cool stuff. And you do have the option to productionize this, right? So you can use things like materialized views to actually aid in building those pipelines, or you can, of course, use some of our upcoming products like Lakeflow and things like that. But the productionization possibilities are pretty powerful here with materialized views as well. We'll talk a little bit about that. So, Federation and materialized views. I think this is a cool slide. Federation loves materialized views, and I think there's a reason for this, right? So like, if I was to go and query it, like let's say for example, you have a particular table in a SQL Server warehouse that you guys, it's widely used, and you're getting 10,000 queries against it a day. Rather than running those 10,000 queries against that SQL Server, right? What you'd most likely want to do is take that data and materialize it in your Lakehouse so that when users are querying it, they're querying it from cloud storage as opposed to querying it directly from the database. Now, before we had any of this, right, what you had to do was you had to create a pipeline, you had to go and use our old Federation technologies to write that data from source all the way down to cloud storage. You had to kind of run your optimizations on it on a regular basis. You had to schedule that pipeline. You had to go through all this like headache and hoopla just to be able to materialize some information and be able to query it in a more scalable way. Well, with materialized views, you can do that with like a click of a button, right? So it's like super simple now. You can effectively, more or less like click on a particular table and create a materialized view from it, or run a simple query and create a materialized view from it. And this is pretty awesome because you can accelerate all the stuff that you might need to do, like for example, cross source joins or like really like complicated transformations. You don't necessarily have to run them on the source database. You can instead run them with the scale of your Lakehouse. And you can also, like as I mentioned earlier, offload the access to your underlying databases, reducing the amount of load that you necessarily have to place on those databases. All right, so looking ahead.
Awesome. Thank you for the great intro. I mean, if I were to say like 2024 was a year of like, first of all, catching up with all the usage I showed you guys because it exploded. So a lot of the work was about scaling, making sure we give you guys the same latency that you're expecting from all these sources. But the second thing we focused a lot on was about, hey, how do I add more data sources so that I can kind of cover like 80–90% of what you need? Looking ahead, right, what we're kind of thinking about is kind of not adding 10 more, 20 more sources, but making the existing work you guys do much more productive and more useful. And we have a bunch of exciting things that are planned on the roadmap. And again, these are all tentative, subject to change. The very first one is remote queries, right? This is the ability for you to completely skip what we're doing with the Spark Query Planner or like, anything that we're doing on our parsing layer and push down a query to that source system. And the main use case for this is, a lot of our customers have UDFs that they have in Oracle, or they have some procedure they want to run, or they have some complicated thing where we may not be able to push down a certain part. And this is a way for you to be able to sidestep all of that and, just push down that entire query against any connection that we might have. I mean, in this example, I gave our Oracle connections, but this will basically work with any kind of thing you have. This is not for all users, by the way. For your regular users, we would still recommend going through foreign catalogs. But for when you need a workaround or when you have a more advanced persona, this is something that can help use that. In conjunction with that, what we're also thinking about is how do we extend the data sources so that you can bring your own drivers and start querying without us having to add something into the system? And that's where the custom connections comes in, along with the remote query that I have. So what we're going to allow you to be able to do is to define a custom connection using a jar or a driver that you have in Databricks volumes, right? and then through remote query, be able to write an arbitrary query against it, and then kind of use that in a way. And our hope is that this covers all that, like, 20% of the databases that we have not covered, because we've been really focused on that, giving that 80% really well. Another big one, we kind of alluded to this, was integration of these foreign catalogs and foreign tables into Lakeflow Connect. So one big thing is, hey, I don't have a CDC connector. You guys don't have a CDC connector, but I still want to use the JDBC-based approach to be able to ingest it. And this gives you just that. So using Lakeflow Connect and the existing Federation connectors, what you can do is you can pick a table, tell us the primary key or like a timestamp column, and then we'll go just do like a basic, last updated, and then ingest it over in a resilient fashion. We'll refresh the query, we'll reschedule it if something fails and all of that. This is still not CDC, by the way, but this should be like, for those of you who are like, you kind of need something a bit more resilient, a bit more scaling, but I don't have full CDC or we don't have a solution for that, this is your solution. Kind of on the other side of this, we've been talking about reads a lot, right? But one big thing that we get asked about is writes, right? How can I insert into this database? How can I create a table in this other system? And how can I do that centrally from my notebooks and Databricks from UC? And we heard you. So we're basically also looking into enabling this. So the goal here is to be able to do basic DML and DDL operations through your foreign catalogs and kind of being able to write back items that you were able to write back before. And this is going to be not a small effort. So within a quarter or two, you'll kind of see it's happening. The other two are requests that we hear all the time, just to kind of cover them quickly. Join pushdowns, right? So that if you have a complicated join, we support this with 50% of our sources, but we're going to add it to the rest of the sources as well. And delta sharing support. So if you have a federated table that you want to delta share to maybe your client of yours or to another organization in your company, you'll be able to do that because we're going to make federated tables work with delta sharing as well. And finally, right, on the catalog federation side, we also have a lot of exciting features, and there's a whole session about this, by the way, if you guys are interested about catalog federation. They have a very cool demo and a presentation about going deeper, dive into some of this stuff. But big things are, let's say you have Glue or HMS, you're going to be able to one-click convert that into a managed table from an external table. This is a huge one. The other one we're working on is Palantir Catalog Federation, right? Being able to federate that and make that available as part of your Unicatalog environment. And finally, having a generic way of being able to do IRC, Iceberg REST catalog, and being able to federate that and make that be a part of your Unicatalog experience. That covers a lot, by the way, things like Polaris, Gravitano, Big Lake, Metastore. Palantir is also technically IRC, but we're gonna have a generic implementation, and then we're also gonna have specialized kind of integrations for each of these tools kind of going forward. All right, so with that, now is the time for a demo. So our plan was to show you all like a quick, 5-minute covering the UI of how all of this set up, showing you some SQL about how all of this is managed, and then kind of just walking you through the end-to-end picture, and then hopefully have 5 to 10 minutes extra for any Q&A. So let me switch over for a second here. All right, cool. All right, so let me zoom in a bit. Hopefully this is good enough. All right, so what you're looking at is our internal staging environment. This is a Databricks workspace. On the left-hand side, you see all the, your catalogs, your pipelines, your clusters. And then I'm in the Catalog Explorer page, right? This is basically the page in Unity Catalog where you can browse your metadata, your tables, your foreign catalogs, all of that stuff. So this is your, center of data. So to be able to set up a connection to an external system, you click on external data. Everything starts with what we're calling a connection. You can think of a connection as a holder for your credentials and host name and user information. So I'm not going to set this up because I already have one set up, but just to give you guys an idea, I will go through this. And just to show you, so you set up the name, you pick the name, right? And you have a bunch of names that you can pick from. In this case, let's just pick Oracle, since that's what we launched recently. I can add a comment. I said next. It's your standard host name. Like, let's just fill this up for a second, just so I can show you the end-to-end flow. And then I'm going to create a pseudo connection. And oh, sorry, Oracle 2. And then now, remember, connection was the holder for your host name and your credentials, all of that information. A foreign catalog uses a connection to basically display all the catalog and the metadata information from that catalog for a given database in that system. So now what I'm going to do is, and this is what's going to appear in your Unity catalog page as a catalog that you can browse and see tables and views. So if you were to do something like this, right, now I'm going to create a catalog in Unity catalog, you see, called Oracle_catalog, using this connection, using this service name. And then what's going to happen behind the scenes is that's going to basically go scan the metadata and show you the thing. Let me actually now show you one that's set up so that we can show you the benefits of this. So I'm going to switch gears 1 second here. So I went ahead and set up and filled, in this case, a Snowflake database, but again, this could have been any database, with some demo tables. So what you're seeing here is, as I am clicking on these things like app, what you're doing is you see sending a metadata call back to the system. You're loading all of this metadata, like about the tables. When I clicked on it, we got the column information from that system. So what's happening behind the scenes is we're grabbing metadata, caching metadata, and making it available to you next time you come in. So all of those things are happening just as seamlessly as you would as an internal table, but behind the scenes, we're doing a lot of stuff to make this metadata magic work. And then when I come in here, right, as we were saying, this just looks like any other table, right? I can add tags, I can add row filters, I can add a column masking rule. There's an AI suggestion, which looks great. I can accept this if I wanted to. If I click on sample data, it actually, kicks off a query against, in this case, Snowflake, to run a limit 100, I think, query, and give me, the thing. I can see the permissions and update and grant other, other principals permissions. As we were saying, I can add policies, right? I can come in here and add a row filter, column masking, all of those things, and it will apply. And then finally, right, the lineage of it, which is a big one. I'm going to come back to lineage as part of the rest of my demo, but the big item here is that once you define a foreign catalog based on these foreign systems, we treat it just like any other table. You get full Unity catalog capabilities on top of it. So now let's switch gears a bit. I'm going to show you all like how some of this stuff is managed in SQL, and then I'm going to jump off to show you some queries on top of them. So the first thing is, when you're creating a connection, you can either use that UI I showed you, especially if you're going to do something like auth-based integration or like any interactive flows, but you can also programmatically manage them. So if I go to SQL, I can basically, I have a mock connection here, right? I can say, create connection as a SQL statement here with whatever the parameters for the specific source I have. And what we'll do is we'll, go ahead and create a connection with these things. And later on, you can also use the SQL command to create the foreign catalog. So we will go scan, the foreign catalog information, connection information, use that, and then, do whatever you want. And then later on, once you have that, you can manage the permissions. The whole point of why I'm showing you this is, once you have your connection and foreign catalog, you can programmatically manage, permissions lifecycle in any policy on top of it, without ever coming to the UI. Once I set all of this up, right, I can actually, either in SQL or in the UI, just start querying this. For example, if I want to do something like show tables, right, what's going to happen is it's going to show you the tables within that schema. I can go ahead and describe the tables that I have, that I get from here. These are all things that are kind of hitting the external systems metadata and coming in. In this case, let's actually run this query very quickly, right? We talked about pushdowns, right? And what's happening here is when I run a query like this is a very basic query. What's happening behind the scenes is we're sending a scan into this table with a limit query and pushing that entire thing back to Snowflake. Let's do something a bit more complicated. In this case, I have a group by with an order, with a limit, with a sum, right? And I run this. So what's going to happen is the optimizer is going to look at this query. It's going to look that I'm going against an external system. It's going to understand that I'm doing an aggregation with an order by and a limit. And it's going to basically determine what operations it can push down to that system plan the query in such a way and do that operation. And when I go to the query profile for that query, which you can go from here, you can actually click on it and see the exact query we're sending down to the federated system. So in this case, I mean, the structure is a bit confusing, but what you see is we did the sum, the group by, the order by, and the limit. So basically, like 95% of this query got pushed down, and this is a very easy way for you to be able to understand what's getting pushed down, troubleshoot, and just understand general performance characteristics. Let's close this up. And you get the idea. And I can take this thing, and I can join it with another table. I can do anything downstream I want. The whole larger point is whatever we can push down to a system, we'll push down. The rest we'll do in Databricks. Just to hit this point across, I built a dashboard using basically this data set that we looked at. And it just rescheduled refresh right now, by the way. So what's happening is as I change the country, and then if I change the channel, and just like that, all of those queries get sent to Snowflake, in this case, run, and then get displayed. You can imagine where I'm going with this. You can do this across multiple sources, multiple joins, materialized, non-materialized, depending on what your needs are. And then behind the scenes, we will just make this work for you automatically. Now, let's say you have a big join, and you don't want to, as Zeashan was saying, you don't want to actually you don't want to do that live, because why would you do like a huge, trillion row join all the time? So in this case, what we're doing is I have my online user activity in one data source, and my churn and returned order activity in Delta in the data lake already. So what I'm doing is I'm creating a materialized view that is scheduled to refresh every day. That is joining these two tables, so I don't have to join them on the fly. And then when I query this now, right, as opposed to going against the data source, I will directly go against this materialized view. Let me quickly show you this materialized view. So when I go here, right, I can see the refresh schedule over here. I can see the refresh status. It refreshed this morning 2 hours ago, for example. And the thing I said I was going to show you all was the lineage, which is, if I now come to see the lineage of it, right, I can see, at the column level, if I wanted to, where each of these things are coming from. In this case, this is coming from this data warehouse, and then this one is coming from a Delta table. In the Zeashan example, you had like 5-way join. The whole idea is this is all fully traceable at the column level, and also governable at that level. And I believe that was it for today.